On December 28, 1908, an earthquake ripped through the Strait of Messina and flattened two cities in under a minute, killing more than 100,000 people. Today, Italy is preparing to build the longest suspension bridge span on Earth, directly across that same fault line, twin towers taller than the skyscrapers around Central Park. A single span twice as long as any suspension bridge ever built, for a price tag that has already climbed past $16 billion. This is the story of the bridge Italy has tried, canceled, and revived for over half a century, and is now betting everything on finishing. The Strait of Messina separates Sicily from mainland Italy by just 3 kilometers of water. But that narrow gap has cut Sicily off from Europe's rail and road networks for its entire modern history. Every car, every truck, every train car must board a ferry to cross, adding hours, an enormous cost to anything moving in or out of the island. Engineers first seriously proposed a bridge across the strait in 1969. Since then, the project has been designed, funded, cancelled, redesigned, and cancelled again by successive Italian governments more than once, after spending hundreds of millions of dollars on planning alone. The obstacle was never really the water. It was what lies beneath it. One of the most seismically violent stretches of coastline in Europe. The same fault system responsible for the 1908 catastrophe that remains the deadliest earthquake in modern European history. In 2025, after decades of false starts, Italy's government gave the project final public utility approval, clearing the way for construction to begin. The plan calls for a single suspended span of 3,300 meters, more than double the length of the current world record holder, carrying 6 highway lanes and 2 railway tracks between 2 towers standing 399 meters tall. Before any foundation work could begin, geologists spent years remapping the fault lines beneath the strait, incorporating seismic data pulled directly from the 1908 earthquake to understand exactly how the seabed moves during a major rupture.
Controlliamo il diametro. I calibri sono perfetti. Procediamo con il getto.
Because the strait sits at the boundary between the Eurasian and African tectonic plates, engineers had to design not for an occasional tremor, but for a structure that could survive a magnitude 7.5 earthquake without collapsing. Wind data mattered just as much. The strait funnels powerful, unpredictable crosswinds between 2 mountainous coastlines, and any bridge built here would need to withstand gusts strong enough to twist a rigid structure apart. The bridge's entire weight will rest on 2 enormous circular foundations sunk into the seabed. A plinth 55 meters across on the Sicilian side and 48 meters across on the Calabrian side, linked by a reinforced concrete crossbeam, built to move with the ground rather than fight it. Anchoring a structure this massive into an active fault zone meant designing foundations that could absorb seismic displacement instead of transferring it straight into the towers above. It's less like planting a flagpole and more like building a structure that can survive being shaken sideways by the earth itself. Rising from those foundations are two towers, each 399 meters tall, roughly the height of a super tall skyscraper, making them the tallest bridge towers ever constructed anywhere in the world. Between them will stretch a single unbroken span of 3,300 meters, more than 3 kilometers of roadway and railway, suspended entirely by cable, without a single support pier touching the water below. That decision wasn't cosmetic. Any pier placed in the strait itself would have to survive both the earthquake risk and one of the busiest shipping channels in the Mediterranean. So engineers eliminated the problem entirely by spanning the whole gap in one piece. Holding that span aloft will be 4 suspension cables, each 1.26 meters in diameter, built from tens of thousands of individual steel wires. Laid end to end, the total length of wire used in those 4 cables would stretch 940,000 kilometers, 2.5 times the distance from the Earth to the Moon. The deck itself is designed as a streamlined, aerodynamically shaped box structure, rather than a flat platform, specifically engineered to let straight crosswinds slice through and around it, instead of catching it like a sail. Combined with tuned damping systems built into the towers and deck, the design philosophy embraces flexibility over rigidity, letting the entire bridge sway and absorb energy during an earthquake rather than resisting it outright. By early 2026, Italy's government had locked in a construction budget of roughly $5 billion and set a target for major works to begin by the final quarter of the year, with a 7.5-year build timeline pointing toward completion around 2033 and first operations in 2034. Wind tunnel models of the deck cross-section have already been tested at reduced scale to validate the aerodynamic design before full construction begins, and seismic simulations continue to run against updated fault data as excavation work advances on both shorelines.
Steady on the left, bring it down slow. Line up the pinholes now. Lock it in, secure the bolt.
But approval on paper has never been the hard part of this project. Italy has gotten this far before. In October, the country's own Court of Audit, the body responsible for reviewing major public spending, rejected the government's proposal to formally greenlight construction funding, raising fresh questions about cost overruns and financial oversight on a project whose budget has already grown by billions since its most recent revival. It's a familiar pattern for a bridge that has been designed, canceled, and redesigned since 1969. A project that has survived changes of government, shifting cost estimates, and now a direct challenge from the very institution meant to keep it honest. The government has pushed forward regardless, insisting the objections can be addressed without derailing the timeline. Whether the Messina Bridge finally gets built or joins the list of Italian megaprojects that collapsed under their own bureaucracy may come down to the next few months of political and financial maneuvering, not engineering. Sicily has waited generations for a fixed connection to the mainland. Whether that wait ends in 2034 or with another cancellation, will say as much about Italian politics as it does about engineering. If you want to see whether the world's most ambitious and most cursed bridge finally gets built, subscribe now, because we'll be tracking it every step of the way.